x beta prime. Okay, these are the old variable, these are the new variable. Okay, as we have studied, already explained, if I transform to f alpha bar, yes, d, that is f mu, which is function of alpha. Okay, d alpha mu will be equal to partial f mu alpha I d alpha I in the previous lecture, and here alpha, all alphas i's are a yes. I have already explained, all will be independent. Their dot product is the 0. Yeah, in the last lecture I have explained. Okay, here alpha I and alpha j, here dot product is, yes, what is the dot product? Now, if they are the same, then the square of the magnitude, and if they are different, then that will be a 0. Mean that will be square of the magnitude. Mean if ij is different, then canonical delta will be 0, then this will be a 0. If they are the same, then that will be the square of the magnitude. Okay. Last time we have proved this. Okay. So if we consider this transformation according to this, yes, in the same way, x alpha, new variable is x bar. Okay, that will be, if that is x bar b, means that must be a same. Okay, that is depending of changing with respect to x alpha, because x alpha. How we may remember that if there is an if you are interested to avoid the mistake, the best way is firstly write what is your new variable. New variable is beta bar. How many indices? There is a one indices. You may write one transformation log. What is the old variable? That is alpha. Firstly write this. This is a trick. Okay, writing the trick. Okay, that is the conceptual. That is trick. Okay. If beta is free indices, here will be beta. This is bar. This will be bar. Here is alpha. So this will be alpha. Upward with the upward. Okay, as I and I, mu and mu and mu bar, the same. Okay, got it? So if I say that this is this is D, that was okay. If I say this is tensor beta bar, okay, so this will be transformed in this. Okay, this is the function of this. Okay, if that is a function f, then that will be transformed in this. Or you may say that whatever the this x, if this x or chi, xi, psi, whatever this is, this will be transformed in this. Now I think it is simple. Okay. So this is contracting with this. These are the dummy indices and these are the free indices. These are the free indices. This is the dummy indices. Okay, that is the difference. Yes? This alpha is contracting with this alpha. This is the this. This beta, as I have in the previous lectures, we have observed that there must be a same, that are the same. Free indices are the same, and dummy indices are different. Or dummy indices is this. Achha, the other thing we have studied that if we are considering vector A and B, one will be a covariant, one will be a contravariant. One will be a covariant, one will be a contravariant. Yes, and last time we have explained it very clearly. So, whenever you take a dot product, one will be a covariant and one will be a contravariant. Okay. So, we know that this is there is a superscript, this is a contravariant. So, we know that this is a So what will be this? If this is contravariant, this must be a contravariant will be contract with the contravariant. Sorry, this was a sorry, I was wrong. This both was a free indices. So there is a summation. Okay, and we have studied that the contravariant contract must be contract with the covariant. This will be a yes. In 1 minute. Okay. If this is a contravariant, this will be a covariant. That's why this division will be. That means this division will be treated as covariant. Yani mean. In the tensor form, if I write this is a partial, this is a this is a covariant derivative. Covariant. Why? Because contravariant will be contract with the covariant. So, according to this formula, if this is a contravariant, this must be a covariant. So then that will be a contract. So this will be transformation. Superscript. Please. First we try to understand, that is the come in the next step. If this is a contravariant, this will be a covariant. So that's why in the real, if superscript is coming, this is a covariant up till here. Okay, that must be clear. Okay, ये clear हो गया? अब कोवेरिएंट की बात आगे करते हैं. मैं अब आपको मुझे पता है वो आप तेजी में आपको नहीं समझ आती. ठीक है, आप आराम से समझो इसे. ठीक है. Why this is a covariant? This is contravariant. So other will be covariant. And what is this covariant? Contravariant is in the form of superscript. So this is actually the. If this is a covariant, then this is must be right in this form. Okay, that is the covariant. Got it? I think it is a very clear. Now we consider the transform. This is transformation of the contravariant to contravariant. Contravariant to transformation of contravariant. The transformation of contravariant. But if we consider the transformation of covariant, if we transform the covariant, now the alpha will be transformed into, this is subscript, this is subscript, so this will, both are covariant. According to the meaning of this are the same, so transformation of covariant will be x alpha is transforming to x beta bar. Yes, now both are covariant. So firstly right side x beta bar equal to one transformation along x alpha and the alpha. Okay. This here and okay. Now, if there is a mu, if there is a mu, then here is a mu. Okay. So, okay, and if this is a beta is subscript, so this will be a subscript. This is a bar. This is alpha. This must be this, because that we must think that must be. Okay. I think now it's very clear, very simple. Okay. So if I say that this is phi beta, okay. I may write in this way. I have replaced this with this. Okay. Got it? I have not used any deep concept. I have simply transformed in this way. Okay. Now, if this is covariant. Okay. This is also covariant. Okay. Then what will be this? Because this is covariant, this must be a as the according to this formula. If one is contravariant, then other will be a covariant. Okay. Okay. So this is a contravariant. This means this is. If something is coming in as a covariant in denominator, then that will be treated as a covariant. And from the last thing, we have also observed that if something is in the denominator is contravariant, that will be a covariant. Okay, so that's why I have repeated all this. So this will be replaced with this, and this will be the same. The meaning is the same. So this contravariant is contracting with this covariant. Okay, now I think there will must be so this is the transformation law of two indices. I think now it is simple and now it is very clear. Huh? Yes, no need to repeat. Okay. So we have understand how the contravariant and covariant will be transformed. These also used in the relativity and cosmology, quantum field theory, string theory, and all these indices also. This type of terminology will be used in your all modern physics lectures. Okay, but usually, as I have already mentioned, that the contravariant is treated as a column. As the original vector, okay, and the covariant usually is treated as a projection. So we try to change these indices, transformation variables. Usually, mostly books and mostly people mostly theorists prefer to use the contravariant indices as a variable, transformation Jacobian variable, instead of using the covariance. So this is the actual transformation based on this transformation. But we replace this transformation, as I have already explained, that this psi beta may be right in the form of that is the most preferable method. This is like old, okay. But now, if you are familiar with the contravariant and covariant, this covariant will be this is covariant, and we are interested to take it a contravariant, this variable as a contravariant, okay. So if beta is at if this is contravariant, okay, and I have already explained that if alpha is actually the x alpha, and if this is in denominator, covariant is denominator, then that will be contravariant. In the previous we have explained. If there is a contravariant, then that will be a covariant. Yes. So if I am interested to take this indices in a covariant form, but Jacobian or transformation variable as a contravariant, then I may write in this way. If that is covariant, then it will be. If this is a covariant, then it will come in a denominator. And this is a covariant. This will be contract with the. So we will use this transformation onward instead of using this. Why? We know that this is a covariant. So that's the beta is covariant. Here beta is covariant. Three indices both are same. Both, and this is a bar. Here is also a bar. Okay. This is a x. Sorry, this is a dummy. This is a dummy. Alpha is contracting with the covariant is contracting with the contravariant. There is a no confusion between indices. Okay, got it? So this will be. You may say that actually we use this transformation for understanding. We will write it in this way. That will be beta bar. Okay, because this is coming. This is a beta. Means this is superscript. So this will be a subscript. Alpha is contracting beta. Okay, got it? So this is the way of the transformation of contravariant and covariant. So this is transformation law of a single rank. Okay. Again, I am repeating so that it that maybe not create problem in next upcoming lectures. Okay. The transformation of single rank tensor. This is the single rank because the transformation law is only one. That's why that is defined as single rank. So single rank transformation again. Transformation of VI. So psi alpha is transforming into psi a bar. Okay, I'm writing again. This will be a psi a, that will be a x. Okay. So yes, please. Yes. Firstly, write this left. So a bar alpha. Okay. I think now it's clear. Okay. Now we are summarizing what we have discussed. Okay. Of covariant. Yes, now you will understand. Okay. Psi A2, psi alpha bar, psi alpha bar will be and so how so now we are transforming the covariant. Alpha A will be so firstly you have write this. This will be a superscript. This must be a that alpha, and this will be a. Okay. Now this is the finalized. Okay. Now question is how the multi-rank tensor will be transformed. Okay. This is a mixed rank tensor. Some indices are contravariant, some indices are covariant. How it will be transformed? This is transforming to the okay. Okay. What is the partial? Sigma and tau. If you are not, if you are confusing with the, you can write theta and phi. Whatever. These are the different indices: alpha, beta, gamma, sigma, and tau. Okay. And that depend upon the variable may be a different. Okay, so that may be a change in a paper too. Okay, so you must know the what is the concept behind it. ठीक है रटा will be not ठीक है रटे से कोई फायदा नहीं होगा ठीक है okay so who will come here and to write this transformation law Anyone will try to? Firstly, you have to write the new variable. Then, how many indices are used here? 5. One, two, three, 5. Okay. Okay. 1, 2, 3, 4, 5. Okay. And then you will write old, alpha, beta, gamma, sigma. Okay. Now, firstly write this. And this is A, B, C with bar. Okay. Then D as a subscript, so it will come here. D, E. Okay. Clear? Again, A, B, C, D, E. Here this is a superscript. Here it will come at denominator. Got it? I have already explained that. Even if the this transformation law is, so this will be contract with this, and if this is a subscript, then at denominator that will become as that. So again, A, B, C as a nominator, and D is A, B, C it is occupied, then D, E. Similarly, alpha, beta, gamma are here is a superscript, so it will become at denominator alpha, beta, gamma, and this is subscript, so this will be as a superscript. Okay. So this is the transformation law of a multi-rank or mixed rank tensor. Okay. No. Bar is, if this is here, there is a 3 bar. Here it is subscript. And in the previous we have. Okay, got it? Any confusion? Okay. So this is the way the transformation of the multi-rank tensor. If that is a mixed rank tensor, if there is some superscript, some is contravariant and covariant, that is a mixed rank tensor, then that will be transformed in this way. Got it? So come to topic. Now question is, what is the physical meaning of this? What is the, we have already explained what is the physical meaning, but now we will prove it. What is the physical meaning of this? So next exercise or next theorem is about prove that Now we have understood how the single rank tensor transform and how the multi-rank. Now we have to prove that the single rank tensor are actually physically the vector. So firstly, we must know what is the vector. I have already explained. The vector have two properties. What vector has a property? Vector component will be transformed. And secondly, it will be transformed in such a way that under all transformation, vector will be transformed in such a way that its magnitude will remain the same. हमने क्या definition पढ़ी है vector की? What is the definition of vector? What is the vector? Under transformation, number one, component must be transformed. Number two, in such a way the magnitude or we have last time there are two type of transformation. One is translational transformation. One is rotation. In both cases, component will be transformed. If we combine a 1 and 2 transformation, the result is we have summarized that the vector will be transformed in such a way that their magnitude will remain the same, but component will be transformed. Okay. Yes. Again, I think that is repeating. That is good thing. Vector has two components. One is in the form of contravariant, one will be in the form of covariant. So this will be transformed in this, and so I am considering both components. Okay. This transformation is component of contravariant. This transformation for a covariant or contravariant. Yes, this. Yes. Okay. So the first thing I have proved that the component are transformed. Okay. Second, what is the second condition? What is the second? Magnitude will remain invariant. Invariant mean will not change. Yes. How we will prove it? Yes. 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 What is the magnitude? Oh, sorry. Magnitude. Magnitude mean the old and the magnitude of the new. That will be the same. We have to prove it. Yes. So I pause here is yes. You may write. I have already explained that is one is column. हमने अल्फा लिखा था, ए लिखा था. Okay, A bar. A. First is column. अच्छा, it is not necessary कि firstly maybe a covariant. There is no condition on contravariant and there is a condition only for the column matrix. Means column of first vector and the row of second vector. That must be a match. Okay. Means if it is this and if you write in this, if you write contravariant first and then covariant, or if you write first covariant then contravariant, it will not affect on the result. In both cases this will be a right. Again, if firstly you write a covariant and then contravariant, if you firstly write the contravariant then covariant, it means both are true, both are right. But column must become column of first vector and row of the second will be contract. Clear? So column must be column indices. The contracting column indices must be at left and right side of row. ये row. So this is column indices. This is a row indices. यानी this is a column. अच्छा, ये बात उल्टी होती है. ये बात गौर से समझने वाली. If you have a column indices, then it is mean that is row. If you have a row indices, then that means that is a column. ये समझ आया या नहीं पता? This is a column indices. Mean आपके पास A भी है, तो ये row है. Oh sorry, this is a row. This is a column. अगर मैं if I am using the semicolon, it means this is a second indices. यानी column indices. Okay, semicolon. I am taking the meaning of the semicolon means the second indices, mean column. Okay. If you have a B, this will be a row and this will be a column. Okay. The first indices will be row, second indices will be a column. Because if I am not using the column, then it means this is the first indices. So this is a row indices, and this is a column indices. And column indices must be same as if you multiply vector A and if you are multiplying A B, the N P B will be P M. Mean column must be same with the row, and the column of the first vector, and row of the same rule will be applied here. The column of first vector and row of, so you must be careful. The first vector column must be matched with the row of the second vector if you are multiplying. Got it? Okay. So that's why I am again stating that you must be careful that column must come before and row must be come. Row indices come in second. Okay. Clear? The one, and what is the other thing I am explaining? And one thing is this, because column and row, this must be the same. So column of first vector must be contracted with the row of second. And all column mean if you have a x alpha, it means x1, x2, x3, and xn. Mean alpha is row element, first row, second row, third row, n row. Means if you have a row indices, then that will be represent the column matrix. Okay? And if you are using the column indices, if column is changing, then that will be a row matrix. Got it? If indices is a column, if indices are row, if row is changing, then that will make a column. If column is changing, then that will make a row. Okay. So, okay. Everyone is asking about this. This is alpha, this alpha. If we put this value, this was a transformation. If I put this transformation law, okay, to apply it here, okay. If I am applying this transformation law, okay, the new variable is this, no, sorry. And this applying here and this applying here, okay. Okay. So I may write in this way. A is changing with the alpha. A is converting to alpha or alpha is converting to A. Okay. So if there is A, row will be transformed with the alpha. Subscript covariant column, and this is transforming contravariant. Okay, contravariant transform to contravariant. Here is bar. Okay, sorry, I have missed it because these are the new. New is transforming the old. Okay, so because both have indices same, then that will be contracting with each other. So the indices will be same. This alpha is contracting with this. Okay. 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 So this alpha must be contract whenever you transform. Okay. This is this is covariant. So I must write A, and here I must write alpha. Alpha will be contract with this. Okay. Again, this new was A bar. No, sorry. Here is bar, A bar, and alpha. Okay. Got it? This alpha is contracting with this is covariant. This is covariant. This is contravariant. This is contravariant. Secondly, here must be a, this is also a column, okay, because it is a column. Column will be transformed in a column, and okay, sorry. Okay. A. Okay. Okay. And this will be yes. Okay. This was A bar. हम कंफ्यूज कर रहे हैं इसको, ये था हमारी टर्म, ठीक है. दिस इज ए बार, दिस दैट्स व्हाई दिस ए, ओके, and this is bar, that's why this alpha is contracting. This is A, this is A bar. Yes, वो actually we are confusing the with other. हम दो एक का एक ले रहे थे, दूसरे का दूसरा था, ठीक है, ठीक है, ये आ गया. Got it? But it is a column must be a column must become column contract with from the left side. So this is a, so it must become here. Because according to the rule, column must be the column of first vector must be the same with the row of the second. So this psi bar can be here. Okay, got it? So psi semicolon alpha x psi alpha. This will be alpha prime A prime A prime A. Okay, this A will be cancelled with this alpha will be cancelled with this, and this will be a okay. So it's proved that the length of the single rank tensor will be invariant. Means you have taken the right hand side and you have proved the So that's okay. Inner product inner product or contraction reduce the rank while outer product increase the rank of tensor. Yes. So first inner product of different multi-rank tensor. Okay, they have a two part. Now, firstly, we will write a first part, then we will talk the other. So inner product means if there is a contraction, means one or two indices are the same. Okay. For example, if you have psi, okay, alpha, beta, gamma, okay, sigma, alpha, beta, gamma, sigma, tau, and other indices is phi, that is alpha, sigma, sigma, alpha, beta, gamma, sigma, tau, and sigma, alpha, sigma, mu, theta, and okay, I think it's enough. Sigma, alpha, or theta. Okay. So these are the two. We are taking the product of two inner product of two because two indices are the same. There is a contraction. The alpha is contracting with the alpha, and sigma is contracting with the sigma. Remaining are different. Okay. Okay. They are the contraction of the two indices. Okay. And you must remember that the contravariant must be contracted with the covariant, and covariant must be contracted with the contravariant. There is no condition. Contravariant may come first and then covariant, or a covariant may come first and then contravariant. I have discussed already. Okay. So let's suppose these are this is transforming from these are transforming into this. Let's suppose this is sorry, this is old, this is new. Okay. Alpha is transformed to alpha is transformed to A, beta is B, gamma is C, and sigma is D, and phi is E. Okay. Okay. So for phi, sigma was D, alpha was A, and theta, let's suppose this is X. Okay. Got it? And these are the new variables. Okay. So this will be new, and this is in old space. Okay. Transformation laws always tell about the what are the order, and this is will never tell about the what are the order of the because there may be some indices are true and there may be of some false. ये हम अगले अभी ये आपको नहीं समझ आएगा, हम अगले लेक्चर्स में कुछ में लेक्चर्स में देखेंगे. There are possible the some for example if you are related to the particle physics, then you must be know about the gamma matrix. They have a they have indices, single indices, and they must it look like that will be transformed like a vector, but it is not transformed as a vector. So that will be not a single rank tensor. So I will explain it later. So this is a okay. Okay. So psi bar A, B, C, D. This transform, sorry. This is transforming into this, and this is transforming into, this are not equal, this is transforming into this. Okay. And this is our transformation, they are not equal. Okay. This vector is transformed into this, and this vector will be transformed, this tensor will be transformed into this. Okay. So firstly, write the transformation law of this. What is the transformation law of this? 1, 2, 3, 4, 5. A, B, C, D, E, yes, what is the transformation law of this? How many the indices are there? And all are, if we are considering all are true indices, okay. So their transformation law will be a 5. So the 5, 1, 2, 3, 4, and 5. Okay. And this is transformed into 5. And what is the alpha, beta, gamma, sigma, tau? Yes. Okay. So this DE is transformed into this. Okay. Now, what is the transformation law of this? Three, 1, 2, 3, 5 bar, no, sigma, theta, alpha. Okay. Okay, so firstly, superscript A, B, C bar, ठीक है, then D, E and bar. Okay. Okay. Now this is superscript will be contract with the contravariant will contract with the covariant. Okay. So it should be in a nominator. Alpha, beta, gamma, sigma, and tau. Okay. Similarly, in this case, yes, D, X, A here. Okay. Okay. And sigma, theta, alpha. Okay. So how many transformation laws here? 3 and 5. 5, 6, 7, 8. 8. One, two, three, four, five, 6, 7, 8. Yes. Alpha, beta, gamma, sigma, tau, sigma, theta, alpha. Okay. May I write in this way? And this is bar A, this is bar B, this is bar C, alpha, beta, gamma, sigma, tau, D bar, E bar, D, X. And this bar is on these, okay, X, okay, and this is bar X, sorry, dx, and alpha, sigma, theta, a bar. Okay. 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 There was contraction between alpha and alpha. So alpha, where is alpha? This is alpha, and here is also this alpha will be cancelled with this alpha. Okay. This A bar will be cancelled with the this A bar, and other was there was contraction between alpha alpha and sigma, D and sigma. Okay. D where is D? D prime. Okay. This D prime is cancelling with the D prime, and sigma is cancelling with the sigma. Okay. Got it? Okay. Yes. 1 minute. Okay. A, B, C, D, E, phi, D, X, A, 1, 2, 3, 4. Okay. 1, 2, 3, and 4. Sigma was alpha, beta, gamma, sigma, tau, and phi was and alpha. Okay. Yes. Okay. B dash, C dash, D, D कैंसल हो गया, E और and then D A X bar. E bar. B bar, C bar, E bar or X bar. Yes. Sorry, I was wrong. X bar. Yes. Okay. Here was beta, gamma, tau, and theta. ठीक है? Okay. So if you observe this, what is the transformation? This is, for example, if I say that is result. This is actually the transformation law of. If I say that this is a bar with, and this transformation law is say that B, C, X, E. B, C, X, E. And result is beta, gamma, tau, and theta. Okay. Yes. tau की जगह थीटा और tau नीचे आएगा. Beta, gamma, theta, and tau. Yes. Okay. And these are the. So this implies that this is a 4 rank. So when we transform this tensor, when we take the dot product of these if we take inner product of between these two, if there are two contraction indices, actually there was a 1, 2, 3, 4, 5, 6, 7, 8, but they reduced to the 4. So it means the contraction will reduce the rank of the tensor. Okay. All this is from the we know from the transformation law. Okay. Got it?